Imagine 3 runners start from the same starting line. Runner A completes 1 lap in 6 minutes. Runner B completes 1 lap in 8 minutes. Runner C completes 1 lap in 12 minutes. They all start together now, but after that, each runner returns to the starting line at different times. The question is, when will all 3 runners reach the starting line together again? Let us list the return times. Runner A returns after 6, 12, 18, and 24 minutes. Runner B returns after 8, 16, and 24 minutes. Runner C returns after 12 and 24 minutes. The first time common to all 3 is 24 minutes, so they will all meet again at the starting line after 24 minutes. This is the need for LCM when we have 3 numbers. LCM helps us find the first common meeting point of repeated cycles. But before we go deeper into LCM, let us first understand HCF with 3 numbers. Imagine you are making goodie bags for a class. You have 6 cookies, 12 chocolates, and 18 candies. Every goodie bag must be exactly the same, and you must use all the treats. What is the largest number of identical goodie bags you can make? If you make 3 bags, it works. Each bag gets 2 cookies, 4 chocolates, and 6 candies. But can we make more than 6 bags? Try 6 bags. 6 cookies can be shared as 1 cookie in each bag. 12 chocolates can be shared as 2 chocolates in each bag. 18 candies can be shared as 3 candies in each bag. So 6 bags work perfectly. Can we make more than 6 identical bags? No, because 6 cookies cannot be divided into more than 6 non-empty identical groups. So the largest number of identical goodie bags is 6. This is the HCF of 6, 12, and 18. HCF means highest common factor. For 3 numbers, it is the largest number that divides all 3 numbers exactly. The rule using prime factorization is simple. For HCF of 3 numbers, take only the prime factors common to all 3 numbers and choose the smallest power. HCF is for sharing, so every selected prime must be shared by all numbers. Now let us solve a worked example. Find the HCF of 12, 15, and 21. First, write the prime factorization of each number. 12 equals 2 squared times 3. 15 equals 3 times 5. 21 equals 3 times 7. Now look for prime factors common to all 3 numbers. The number 2 appears only in 12. The number 5 appears only in 15. The number 7 appears only in 21. But the prime factor 3 appears in 12, 15, and 21. So the only common prime factor is 3. Its smallest power is 3 to the 1. Therefore, HCF of 12, 15, and 21 is 3. For HCF of 3 numbers, a prime factor must appear in all 3 numbers. If it appears in only 2 numbers, it cannot be part of the HCF. Now let us move to LCM of 3 numbers. Think again about the runners. One runner returns every 6 minutes, another every 8 minutes, and another every 12 minutes. We are not trying to divide something. We are trying to find the first time when all cycles meet. That is exactly what LCM does. LCM means lowest common multiple. For 3 numbers, it is the smallest positive number that is a multiple of all 3 numbers. The rule using prime factorization is simple. Take every prime factor that appears in any of the numbers and choose the greatest power. Find the LCM of 6, 72, and 120. First, prime factorize each number. 6 equals 2 times 3, or 2 to the 1 times 3 to the 1. 72 equals 8 times 9, so 72 equals 2 cubed times 3 squared. 120 equals 12 times 10. That's 2 squared times 3 multiplied by 2 times 5, so 120 equals 2 cubed times 3 to the 1 times 5 to the 1. Now list every prime factor that appears anywhere. We see 2, 3, and 5. For prime 2, the powers are 2 to the 1, 2 cubed, and 2 cubed. The greatest power is 2 cubed. For prime 3, the powers are 3 to the 1, 3 squared, and 3 to the 1. The greatest power is 3 squared. For prime 5, it appears as 5 to the 1, so we take 5 to the 1. Now multiply the greatest powers. LCM equals 2 cubed times 3 squared times 5. That's 8 times 9 times 5, which equals 360. So the LCM of 6, 72, and 120 is 360. HCF takes only what all numbers share. LCM covers them all, and the product shortcut belongs to two numbers only. Now comes an important warning. In the previous lesson, we learned a beautiful rule for two numbers. HCF times LCM equals the product of the two numbers. For example, for two numbers A and B, HCF of A and B times LCM of A and B equals A times B. But do not extend this rule blindly to three numbers. Let us test it with 6, 72, and 120. For these three numbers, the HCF is 6 and the LCM is 360. So HCF times LCM equals 6 times 360, which is 2,160. Now multiply the three original numbers. 6 times 72 times 120. That equals 51,840. 2,160 is not equal to 51,840, so the product rule does not generally work for three numbers. Sometimes, in special cases like 8, 9, and 25, the numbers do not share prime factors with each other, and the result may look like it works, but that is a special situation, not the general rule. The HCF times LCM product rule is guaranteed for two numbers, not for three numbers. Now let us bring everything together. Today you learned how to find the HCF and LCM of three integers using prime factorization. For HCF, you look for prime factors common to all three numbers and take the smallest powers. HCF is useful when you are dividing items into the largest equal groups. For LCM, you collect every prime factor that appears in any of the numbers and take the greatest powers. LCM is useful when you are finding the first common meeting point of repeated cycles. And finally, you learned an important warning. The HCF times LCM equals product rule works for two numbers, but it does not generally work for three numbers. So remember, HCF is common to all, LCM covers them all, and the product shortcut belongs to two numbers only.